Good morning. It's quite an honor to be here. And I do have a confession. I have 32 years with Shell. First 26, 27 were with the pipeline industry. And when I arrived here 4 years ago, I had a full head of hair and weighed 150 pounds. So this is a tough business. But no, when I got the call, it was really neat to be able to come. And we're going to share this in two parts. The first part are some challenges we have right now in the industry, and it's a veritable cornucopia of them. But I want to finish with there's a lot of opportunity, and that's what I'm excited about. And I think y'all in this room, just like Mr. Mitchell, didn't say no when people wanted him to say no. I think we have a lot of opportunity in the wind industry and some of the other industries. And what you'll find out is that the wind is not unlike oil and gas in a lot of respects. So let's see, next. Okay, you don't have to read this. My lawyers make us put it in here, and if you want to read it, you can come afterwards. I'll read it to you, but just don't go out and buy stock after I talk. Everybody's happy, so we'll go. So anyway, we'll start with sort of an overview. The previous speaker talked about the energy doubling by 2050. That's absolutely right. We believe that too. And you take a look at wind, and Shell believes wind is a piece of the puzzle, just as clean natural gas is, biofuels, and things like that. And when you look at the generation costs, we saw a graph earlier. Wind wasn't on there, but the overall spectrum is coal, unscrubbed coal is about 6 cents a kilowatt hour. Scrubbed, cleaned up coal is about 10 to 11 cents a kilowatt hour. Natural gas, depending upon gas prices, sits in the 6 to 9 cent range. Wind is approximately 11 cents without incentive. Hydro is about 13. Nuclear is about 14 cents a kilowatt hour, but that does not include fuel rod disposal costs. So I think you have to take that into account. And then solar sits around 30. And so wind is competitive. It's not 3 times, it's not 2 times, it's competitive. And one of the opportunities is how do you combine the wind with other sources to get there. The power prices, because of all this natural gas coming on the market, we're seeing power prices do some very funny things. Here in the state of Texas, where they were 30 cents, they're dropping into the 20s. In the Midwest part of the United States, we've seen 30-cent power prices drop into the teens. On the East Coast, we're seeing power prices drop from 50 cents into the 35-cent range. But in California, we're seeing power prices go from 55 cents to 90 cents. And the other thing, you can sell 3 things off of a wind turbine. You can sell the electron, you can sell the tax equity, and you can sell the renewable energy credit. And so the renewable energy credit, we're seeing those prices do some funny things. We're seeing them drop from $5 a rec to $1 a rec in several places. In California, we're seeing them go from $5 a rec to $35 a rec. So to have 2 wind farms in California, which we do, it's a wonderful place to have a homegrown electron in the state of California. The problem is we also have wind farms in Iowa, West Virginia, Wyoming, and Texas where the prices aren't going that way. But the prices are depressed. And in order to fund one of these, we need about a 15 to 20 year PPA, power purchase agreement, to go out and get a loan. And the problem is everybody's reticent to sign up for these right now because not knowing what the gas prices are going to do, how many coal plants will be retired, how many natural gas plants are going to be put in, it's a guessing game, and so everybody's just laying low saying, you know what, I'm not going to sign up for a long-term price, not knowing what's going to happen in 2 or 3, 5 years. So uncertainty there. Transmission lines, I know we'll talk about that in a few minutes, I think, with ERCOT, but to build a transmission line, if we all in this room decided we were going to build a transmission line, we'd probably be 6 to 9 years older before it got built. All the permitting, all of the contracts, the studies, and everything like that. Plus, if you mentally picture the United States, All the wind is in the central core of the United States pretty much, gathered around Colorado and what have you, and the load centers are out at the coasts. And so you have to move the electrons around. You can talk about smart grids all you want, but as an old power engineer, I'll tell you, you still need copper, steel, and aluminum to move that electron around from where it's made to where it goes. More interest from stakeholders. This is code for everybody wants to play in this business now. We have been sued by the Friends of the Flying Tree Squirrel up in West Virginia. We have all kinds of eagle and bat and avian issues. We do extensive migration studies before we build our wind farms and during it. We actually built and operate an overseas wind farm in Holland. We have underwater sonar there, and we can tell you every fish that goes through. We can tell you that the marine interests were very worried about the offshore wind park because they thought the fish hatchery would be hurt and killed. Well, in reality, the fish are flourishing because the mussels are growing on the pylons. I'm trying to figure out a way to actually harvest these mussels and sell them as green mussels because I think it would be a good deal. But we can tell you every cod that goes through there, every porpoise that goes through there. And since our wind farm is no longer a navigation zone, there's no ship traffic. So we find some very, very interesting things. Wind farms are built out in the middle of nowhere. In Pipeline, I thought we had the middle of nowhere in the right-of-way. Many of these places are 3 hours from any airport. And what you have out there is generational land. These ranchers, they don't have 401k plans like we do. They don't have retirement plans. And they're trying to figure out how to leave something for their heirs. And so, as a result, they want to build this wind farm. Right across the street, you have the people who come out from the city who build these ranchettes and want to play effectively green acres on the weekend. And they'll do a little bit of farming and ranching, cut the grass, and they'll want to sit on their porch at night. Well, what is the last thing you think they want to look at as they sit on their porch on a Friday night and look out across the horizon? It's a wind farm. So we have been able to actually go out, and we have a method that we can actually survey in about 50 points on the new site. We build a 3D digital world. We program in the exact turbine, and we can come and sit on your front porch and bring a laptop computer and show you what you will see on the horizon. And we can change the sunlight and the time of season and every other thing. And so we have ways, but the environmentalists are really, really coming out. Even the folks with the water rights, folks with, I have to get these turbine blades and these nacelles through the town. How do you get them through the towns and everything? So, and then carbon policies are in flux. We could probably talk 5 hours about this, but basically the production tax credits, carbon values and things like that. So I worried that I needed a graph for y'all this morning with all the numbers. So I brought you a graph. And everybody asks us if a wind farm makes money. And the answer is yes, we do. It makes money and it makes cash. And I brought this to show you what this thing looks like. Development period is very long. It's a wind farm takes 6 to 9 years. We'll spend 2 years just getting wind data. We will spend another 2 working on permits, then we'll site it, order the turbines, and everything. The actual field construction is about a year. It's very short. It's a very, very cookie-cutter approach. So if you look at the blue and the white, those are the construction period, but you have several years of development up until that point. And then after that, everything above the line is money that you have coming in. And so the yellow is selling your REC, selling your power, it's your PPA, it's your revenue coming in off the electron. Then you look at the brown, that's the production tax credit, that's the 10-year tax credit we get. Then you have the turquoise, which is accelerated depreciation. So that's all the money that you have coming in. You look down below, that first purplish bar, lavender bar, is our maintenance and operations. Then you have the taxes. You do pay ad valorem taxes and everything. And then you have below that paying back your capital and your interest payments. Now, that red line that you see is the cash flow line. So these things pay out after 6 to 7 years. They stay cash positive pretty much, but they hit that area down there. I call it the valley of despair between years 10 and 15 when you're still paying off things and going. And so our job going forward is how to move that red line up and make more in the future. So here are the opportunities given that, and the wind industry is a great combination of exploration and production and manufacturing and pipelines, if you really look at it. It's not a fancy green job thing. It's basic blocking and tackling. And so we're seeing safety over the last 4 years has truly improved. The workforce is stabilizing. We're finding universities, Texas Tech has done a lot of work, U of H, a lot of junior colleges are getting energy training programs in that the wind workers can train in and everything. The turbine and installation costs are going down. Turbine costs in the last 4 years have dropped about 30%. And the installation costs have dropped about 10%. The problem is your PPA costs and everything else has dropped. Newer technologies are being introduced. And wind turbine's a wonderful thing. It's 13,000 parts, and it's basically metal, electronics, and fiberglass. And it's just put together in a very interesting way. And a lot of the turbine manufacturers are coming up with different blade designs, different electronics, different ways to capture the wind. I see a huge market in the 35,000 turbines we have installed now on the efficiency. Each point of efficiency for us in Shell Wind is $1 million a year to the bottom line. So, you know, we are working on how do you convert that wind molecule into an electron coming out? How do you sense the wind and control your machine and things like that? The reliability-centered maintenance, for the longest time, the wind industry was controlled by what I'll call developer flippers versus a developer operator. And there's a very big difference there in that a developer flipper wants to build it, sell it, take their money and run, and then the poor person holding it is just left, okay, how do I operate this? And you saw that cash flow line below, that red line goes down, and so going out in the future, what do you work on? And so we're actually installing reliability center maintenance programs that we use offshore and in our refineries on our wind turbines. We have a lot of data coming off of turbines. We have 132 data points typically. We can tell you every temperature, pressure, vibration that you can imagine, but there's not a lot of information. There's a very big difference between data and information. Improved wind forecasting is a huge one. We live and die by this. Not only on when we can do maintenance, but if there's a lightning storm, we have to keep our folks out of the tower. But our power traders use this because they're trading power on 5, 10, 15, 1-hour look-aheads, and any piece of information they have ahead of time that they can use, they can make a trade on that or figure out what's going on. The energy storage, I think they'll talk a little bit about that. This is one of the holy grails. Whether it's underground compressed air storage, battery, flow batteries, or what have you. But you can also look at, is there a way to turn each little turbine into its own little UPS and use small battery packs on each turbine? Instead of this holistic solution, is there a micro solution? And then recycling scenarios, I still believe this one is going to be huge too. There's about 35,000 turbines out there right now. We buy these for a 20-year life. The intent is either you take them down at the end of 20 years or you repower them. And there are 3 blades on each turbine. They're fiberglass. Right now, when we get rid of a blade, it's cut up into 10-foot sections and it is thrown in a landfill. So, you know, what do you do going forward on that? So I'll just close real quick. The one thing that I wish I was 30 years younger for various reasons, But I do believe that the engineers coming out of school right now and the young people getting involved, and if you look around this room, there's a fair amount of gray hair here. It would be nice to have a lot less gray hair, because we're handing these things off to a new generation. And the kids who were in the picture earlier are going to be dealing with this stuff. So there's a lot of opportunity out there.